Hello everyone, and welcome to another tutorial brought to you by CG Tuts Plus. I'm Joshua Jorgensen, and today I'll be showing you how to create an interesting pie chart effect like the one shown here. To complete this tutorial, you will need the following software: NewTek's Lightwave 3D and Adobe's After Effects. I will be using Lightwave version 9.6 and After Effects CS4, but earlier versions of either software will work for this effect as well. This tutorial is an intermediate level tutorial. Working knowledge of the interface in Lightwave, along with modeling tools, keyframe animation, and expressions, and a basic understanding of After Effects will be necessary to complete it. The modeling that's required for this tutorial is pretty simple. We'll be creating two objects: a floor object that the pie chart will sit on, and the pie chart, which is the object that will ultimately be animating. Let's begin with the floor object. To model the floor, use the box tool. In Lightwave, when I'm creating objects like this, I prefer to enter their measurements numerically rather than eyeballing them. In the final scene, the floor fills the entire space, so let's make the floor object really large. Create the floor on the y-axis, then make the width 500 meters and the depth 500 meters. But let's make the height 0 meters. This will ensure that we're making a plane as opposed to making a box. Leave all of the other values, the center, the radius segments, and the segments, at their default settings. This completes the modeling of the floor object. Before we save it and move on to the pie chart object, let's define a surface for the floor object. Name the surface something appropriate like floor, leave all the other values at their defaults, and press OK. After this is done, we can save the object. The pie that we'll be creating will be a disc that will have 400 slices. We want the pie to have slices that are a multiple of 100 to make it easier to animate the individual percentages. The reason we're going to use 400 is because the pie will not be subdivided, and smoothing will only be achieved through shading, so it needs to have enough segments to appear smooth. Let's begin by selecting the disc tool. As before, I will enter the measurements numerically. Create the disc on the y-axis, same as the floor. For sides, let's enter 400. Segment should remain at 1, the bottom should be set at 0, and the top should be set at 25 meters. The center will auto-populate for you based on the top and the bottom, as will the Y radius. The X radius should be 50 meters, and the Z should be 50 as well. Next, let's begin creating the slices that we'll need to animate the pie chart. To create the slices, we're going to need to create a pole at the top and the bottom of the pie. Currently, the top and the bottom of the pie are made of one polygon each. We need them to be made of triangles that radiate out from a central point. To do this, select the top and bottom polygon. Then go to the Multiply tab. Under the Multiply tab, you'll find a section called Subdivide, and under that you'll find a button that's labeled More. In the Morph layout, there's a tool called Make Pole. When you run that tool, you'll find that it did exactly what we needed it to do. It made a point in the center of the two selected polygons, and then it connected that point to all of the outer points in the circle. Even though we've divided the pie into slices, the object is still one piece. We need the pie to be divided into 100 separate pieces. To do this, we're going to select all the polygons that make up 1% of the pie, and then invert the selection. Because the disk that we created has 400 segments, 1% is actually 12 polygons. 4 polygons on the top, 4 polygons on the bottom, and 4 polygons on the side. After you've selected 1%, invert the selection. With the other 99% selected, delete the selection. What you're now left with is 1% of the pie with the sides open. We need to close those sides. To do this, select all the points that make up each side. Select them in a clockwise motion. If you select them counterclockwise, the resulting polygons will have their normals facing the wrong direction. After you've selected them, go to the Create tab and press the Make Polygon button. Do the same thing for the other side. Once you finish this, what you're left with is one completely enclosed percentage of the pie. We need to replicate our 1% slice in a circle to create the other 99 slices. To do this, go to the Multiply tab and use the Array tool. Our array is going to go in a circle, so let's use the radial array. The number of slices we need is 100. Everything else should already be set up. The y-axis and the center should be 0, 0, 0. Make sure you do not turn on merge points. Doing that will defeat the purpose of having each object separate, as it will merge them all back together. When you press OK, what you're left with is a disk that looks exactly the same as it did several steps ago. The difference is now it is made of 100 separate pieces instead of one giant piece. The next part of the tutorial can be very repetitive and time-consuming. I'll show you what to do a few times, and then we'll jump forward to a time after I've completed it. In Lightwave, there's no way to animate polygons and points directly, so we need to create a morph map that will make each of our slices appear to grow and shrink. We don't need to worry about anything except for the top of the pie. So for now, let's hide everything else. Select all of the polygons that make up the top of the pie, then invert that selection. This will select everything else. Now we can hide the selection. With those polygons hidden, all you should see is a flat disk that makes up the top of the pie. At the bottom of the interface, you'll notice buttons labeled W, T, M, C, and S. These are vertex maps in Lightwave. We want to use morph map, so click on the M. You'll see that we are in the base morph map. That's the object as it exists with no morph applied. If you click on that, there'll be an option to create a new morph map. Create a new morph map and call it shrink 001. With that created, select all of the slices that equal 1% of the pie. Move those selected polygons down 25 meters in the y-axis. After that's done, you can hide the selection. Now we just need to do that same thing 99 more times. So create a new morph map called shrink 002. Select the polygons that make up the second percent of the pie and move them down 25 meters in the y-axis. In Lightwave, if you open the numeric panel, it will remember the values that you used for the tool the last time you used it. So all you have to do is select the Move tool and then press the Apply button in the numeric panel, and it will move the polygons down exactly 25 meters, the same as it did last time. Hide the polygons. Create a new morph map called Shrink 003. Select the polygons. Move them down. Hide the polygons. Create a new morph map called Shrink 004. Select the polygons. Move the polygons. Hide the polygons. New morph map called Shrink 005. Select the polygons. Move the polygons. Hide the polygons. Create a new morph called Shrink 099. Select the 4 polygons that make up 1%. Move them down 25 meters in the y-axis. Hide them. Create a final morph called Shrink 100. Select the polygons that make up the slice. Move them down 25 meters in the y-axis. And there is no need to hide them at that point. Alright, you made it all the way through. If you unhide everything that's hidden now, what you'll be left with is a pie that has one slice down on the ground. That's our 100th slice. If we look at the list of all of our morphs, there should be 100 of them in your list. By selecting each one, a different slice should go down. So if we select that one, the one next to the previous one went down, and so on and so forth. That completes the modeling for this tutorial. Before we move on, let's assign a surface to our entire pie. Let's call the surface something like pi. Leave all of the other values at their default for now, and press OK. Now we can save our object. I'm going to call mine pi. The next tutorial will be focused on layout. We'll take the objects we've just created and put them into Lightwave layout and compose our shot by setting up our lights, our camera, and setting up our objects to later be animated. Now that the modeling of the elements is complete, we can begin laying out our scene. First, let's load our 2 objects into layout. You'll notice that the grid size is really high. That's because Lightwave tries to guess, based on the scale of the objects, the most appropriate grid size. Larger grid sizes make navigating a scene with small objects slower. So let's change our grid size. Currently it's set to 200 meters. Let's change it to 20 meters. Also, while we're in the options panel, let's make sure our scene is set up to be 24 frames per second. After that's done, let's set the output resolution for our scene. Select the camera and go into the camera properties. Let's change our output resolution to 1280 by 720. After you've done this, go into the render options and turn on the switches to render both shadows and reflections. Let's also turn on global illumination while we're here. Keep everything at their default values. With global illumination turned on, let's change our backdrop color. To 32, 32, 32. The global illumination will use the background color to help light the scene, so this will lighten it up slightly. Now that we've set our output resolution and render options, let's position our camera and light. Select the camera and set its position to 0 in the x-axis, 250 meters in the y, and negative 250 in the z. Set its rotation to 0 in the heading, 45 in the pitch, and 0 in the bank. Next, let's configure and position our light. Select the light and enter its properties. Change the light type from distant to area. With the light properties open, let's change our ambient light color to 255, 255, 235. This will give our scene a slight yellow tint. Next, let's move the area light. Let's move it to negative 175 on the x-axis, 250 on the y-axis, and negative 175 on the z-axis. Leave the rotation of the light at its default values, which should be 45 degrees in the heading, 35 degrees in the pitch, and 0 degrees in the bank. If you were to do a test render now, you'd see that the shadows have a really hard edge. We'd like the shadows to have a soft edge. To achieve the soft shadow, we need to scale the light up. With the light selected, enter its size, and change the size from 111 to 150, 150, and 150. Now if you do a test render, you'll see that the shadows are quite grainy, but they are the soft shadows that we're looking for. When you do your final render, the shadows can be smoothed out by increasing the anti-aliasing. I just noticed that if you look in the corners, our floor object isn't big enough to fill our entire space. So let's scale our floor object up. Select the floor object, enter its size, and change it to 1.5, 1.5, and 1.5. To finish up setting up the scene, let's edit the surfaces of our two objects. Open the surface editor and select the floor surface. Change the floor color from 200, 200, 200 to 235, 235, 235. Increase the reflection to 50% and increase reflection blurring to 50%. Next, let's select our pie surface. Change the pie's luminosity to 25%. We'll worry about coloring the pie a little bit later on in the tutorial. Now let's save our objects and our scene. In Lightwave, surface settings are saved with the object, while object positions are saved in the scene. So if you make changes to the surface in layout, you need to resave the objects. This finishes up the layout of the scene. The next thing we'll do is set up controls so that we'll be ready to animate it. Select the pie chart object and open its properties. Under the Deform tab, add the displacement controller called Morph Mixer. The Morph Mixer provides an interface to apply the different morphs to the object that were created earlier. Although this is handy, this isn't the way that we'll be using the morphs. We're going to be controlling the morphs through expressions. The channels needed for the expressions can't be exposed to the graph editor unless you add the Morph Mixer displacement controller, which is why we did it. For the expressions to interact with the scene, we're going to have to create a very simple UI to control them with. That UI is going to be made of 3 null objects. Create the first null object and call it Morpher. This null will control the rising and the falling of the first piece. Move it out of the way so that we can see it better. I moved it to 75 meters in the x-axis. Create a second null and call it Delayer. This null will dictate what interval of time will pass before the second piece follows the first piece, the third piece follows the second piece, and so on. Move that out of the way to someplace where you can see it, like 100 meters in the x-axis. Create a third null called Switch. This null will allow us to shut off the effects of the first null, so that later we can animate the pieces by hand. Move that to 125 meters. Now we're going to begin writing the expression so our nulls are actually doing something. Open the graph editor and create a new expression called grow shrink. For its value, enter the following. Morpher .pos time close parentheses .y. What this does is whatever channel we apply this to, it will mimic the morpher's y position at that given frame. Let's apply this expression to the first morph channel and see if it does what it's supposed to do. So select the pie chart object, and then in the channel bin, find the first morph channel. With it selected, hit apply to apply the grow shrink to that channel. If that worked, then moving the morpher null up and down in the y-axis should control the morph. As you can see, it does work. But the values are backwards. Moving the null down makes the morph go up, and moving the null up makes the morph go down. Let's fix that right now. Go back into the graph editor, and on your grow shrink, edit the expression and add times -1. So now what it will do is tell whatever channel it's applied to, in this case the first morph, to mimic the inverse of the morpher's y position. Let's see if that worked. So now moving it up should make the piece go up. It appears that that worked just as it was supposed to. Next, let's create the expression that we're going to need to use the delay null. Open up the graph editor and edit your grow shrink expression in the following way. Where it says time, change it to time minus open bracket delayer period position period y close bracket divided by 24. Now what the expression is going to do is, instead of following the morph's y position at the current playhead's time, it's going to do it at the time minus whatever the value of the delayer is in the y-axis. The divided by 24 is because our scene is at 24 frames per second, and we want to calculate our delay in frames and not in seconds. So let's test this out. Currently, if you move the morpher null up and down in the y-axis, it will apply the morph accordingly. And it will do it at the exact same time that the morph null moves. Our delayer null is set up so that it can offset that value. So let's create a short animation with the morpher null. At frame 10, create a keyframe with the null at 1 meter. So now over the course of those 10 frames, the morph moves up, and as the morph moves up, the animation gets applied. If we were to move our delayer null up in the y-axis, let's say to 2 meters, now the morpher null will still start moving immediately, but the slice won't follow until 2 frames afterwards. So you see, the animation doesn't start until frame 3, even though the null is already moving. And here the null has stopped, but the slice still goes until frame 12. To show a more extreme case, let's change the delayer to 10. So now you'll watch the morpher null will move up for the first 10 frames, but the slice won't do anything until frame 11. Then it will start doing what the morpher told it to do. Let's reset everything back to their default values before we move on. So put the delayer null back to 0 and delete the keyframe on the morpher null. Now let's create the expression for our switch null. Open the graph editor and create a new expression. Call this new expression OnOff. And for its value, enter the following: map range, open parentheses, open bracket, switch dot position dot y, close bracket, comma, 0.000, comma, 1.000, comma, open bracket, grow, shrink, close bracket, comma, value, close parentheses. What this expression does is it looks at the y position of the switch. If the y position of the switch is at 0, it executes the grow shrink expression. If the y position of the switch is at 1, it uses whatever value the affected object is keyframed at that point in time. Let's test this expression to make sure it works. What we'll need to do is select our pi object, then select the first morph channel, and remove the grow shrink from it, and apply the OnOff expression to it. The grow shrink will not actually be applied to any of the channels. It's only there to be referenced by the OnOff expression. So our current value for the first slice is keyframed at 0. Let's move to frame 10 and move our morpher null up to 1 in the y-axis. You see that does exactly what we want it to do. The slice follows the morpher null. But it's getting its values from the morpher null's data. The slice is still actually keyframed at 0, even though it's at 1 right now. So if at this frame we were to set a keyframe on the switch, then go forward 1 frame and move it to 1, which would effectively shut off the morpher null, the slice will snap back down to whatever it's keyframed at, which is 0. So now the slice is controlled by the morpher null from frames 1 to 10, and then at 11, because the switch turns on, it's controlled by its own keyframes. With that test done, let's delete all the keyframes we made to set everything back to their default values. Then we'll move on. Now that we've finished the 2 expressions for one slice, we can go on to create all the expressions for the other slices. We'll need 2 expressions for each slice, so 200 expressions in total. As before, I'll show you how to do it a few times, then we'll test it to make sure it's working. Then we'll skip ahead to a point after I've completed it. Open your graph editor and pull up your expressions. We'll be interacting with the channels in the pie object, so make sure the pie is selected. First, let's change the name of our grow shrink expression to grow shrink 001. Then let's change the name of our OnOff expression to OnOff 001. Inside the OnOff expression, it references the grow shrink, but we've changed the name of grow shrink, so make sure you change that reference. Change it to grow shrink 001. And make sure the OnOff 001 is assigned to the first morph. After this is done, we can clone our grow shrink 001, change the name to grow shrink 002. Inside the value of the expression, we don't want the delayer position to dictate the second slice's delay. We want it to be twice as long, because we don't want the second slice to follow the null. We want the second slice to follow the first slice. So change it from divided by 24 to divided by 24 times 2. Clone your OnOff 001. Call it OnOff 002. And change the value so that it references grow shrink 002. Then assign OnOff 002 to the morph map shrink 002. Now we just need to do this same thing 98 more times. So clone grow shrink 002, change the name to grow shrink 003, change the value from times 2 to times 3, duplicate OnOff 002, change the name to OnOff 003, and change the reference inside from grow shrink 002 to grow shrink 003. And apply that to the third morph. Clone grow shrink 003, change the name to grow shrink 004, change the value from times 3 to times 4, clone OnOff 003, change the name to OnOff 004, change the grow shrink reference from 003 to 004, and apply this expression to the fourth morph. Let's do it one more time, then we'll test it, then I'll leave you on your own. So we're going to clone grow shrink 004 and change the name to grow shrink 005. Then we're going to change the times 4 to times 5. Now we're going to clone OnOff 004 and name it OnOff 005 and change the reference inside from grow shrink 004 to 005. Then apply this new expression to the fifth morph. Okay, now that we've done 5 of them, let's test it to make sure it works. Let's animate our morpher null to move up to the 1 meter mark in the y-axis at frame 10. Currently, since there's no delay set, all the slices should go at the same time. And they do. So let's set a delay. Let's set the delay to 3 frames or 3 meters. Now if we scrub through, the first slice should go 3 meters after the null, the second slice should go 3 meters after the first slice, and so on and so forth. It's a little bit hard to see because of the angle, so for now, let's just rotate the pie around. So select the pie and rotate it 180 degrees in the heading. Now if we scrub through the timeline, the effect is much more apparent. Put the pie back to its original orientation for now, and let's continue on with the morphs. Clone grow shrink 005, change the name to grow shrink 006, change the multiplication value from 5 to 6, clone OnOff 005, change it to OnOff 006, and change the reference inside to 006. Then apply that to morph 006. Last one. Clone grow shrink 099 and change it to grow shrink 100. Inside, change the multiplier from 99 to 100. Clone OnOff 099 and change it to OnOff 100. And then inside where it references grow shrink 099, change that to grow shrink 100. Now apply that to the last morph. Okay, with that done, let's save the scene so that we don't lose everything we just did. Now let's test what we just did. If we select our delayer, let's put it at 2 meters. And then let's make a keyframe on morpher at frame 10 at 1 meter. Now if we scrub through the timeline, all of the pieces should work as expected, where they delay by 2 frames behind the piece before it. To see the effect a little bit better, let's rotate the pie around again. Perfect. Let's reset the pie back to 0 rotation, and let's reset our nulls back to their original places. This is as far as we have to go in setting up the scene for animation, but I'd like to take it one step further, just to make it a little more convenient to animate. what we're going to do is we're going to replace these nulls with sliders that we can use to control everything. The reason we're going to do this is because all the nulls are affected from values of 0 up to 1 meter. In a scene where objects are so large, that's barely any movement at all. So it's hard to tell when you're actually animating something. So let's create a new null. Let's call it controller. And open its properties. In the Geometry tab, add a custom object called sliders. If we open up the interface for sliders, you'll see channels listed on the left and selected channels on the right. Selected channels is empty. That's going to be what the sliders are going to control. So let's add some channels to it. First, let's add the Y position channel of morpher. And for value, we want it to go from -1 to 1. And let's change the name of it to something like morpher. Okay, then we want to add delayer on the Y position. And its value should go from 0 to, let's say, 10. And change its name to delayer. Then let's add the Y position of the switch and make it go from 0 to 1 and change the label to switch. If you press continue, you'll see our 3 sliders. In Lightwave, to manipulate the sliders, you need to make sure that in modify, the sliders button is active. Once it is, you can move the slider interface wherever you'd like, and you can control the sliders. You see, when we move the morpher one, currently the entire pie grows and shrinks. That's because the delay is set to 0. If we were to set the delay to something higher, and then animate the morpher, you would see the effect. For example, if we go to slide 10 and change the morpher to 1, you should see the slices animating as they were before. So let's reset all of our values back to 0 again. With the slider set up, we can hide these 3 nulls from the scene because we really don't need them there anymore. So open up the scene editor, find those 3 nulls in the list, and turn their visibility off. What we're left with is a very clean looking scene that we can use to animate.